Welcome to the second creative track tutorial of the year, Sprite Sheets and Tilemaps. I, Ray, will be going over Sprite Sheets, and Zoe will be going over Tilemaps. So, before we get started, let's go over what exactly a sprite is and why sprite sheets are important. A sprite is a 2D image or animation that's separate from the background of a scene. It can also be defined as a box with variable alpha channels, which represents transparency in a range between 0 and 1, from transparent to fully opaque. Now, a sprite sheet is an image file that contains multiple sprites. It should be arranged in like a grid, so it'd be easy to it's easy to separate the sprite sheet into multiple sprites. So it's better to make a sprite sheet containing a lot of the sprites you want to use instead of importing each sprite separately into the game. Definitely sounds like it'd be a lot more efficient to only have to import one image file versus multiple, right? And another thing is that it reduces the number of draw calls and which improves the performance. So for each image you're putting into the scene, Unity will make a draw call for it. A sprite sheet would just be one image file. So even if you have multiple sprites generated from the same sprite sheet, that's only one draw call. While for separate individual sprites, that's a draw call for each separate sprite. When you're making art assets, there are different things you consider if you're making pixel art or raster art, which is basically any non-pixel art. So for pixel art, a pretty standard size of sprites is 64 by 64. And the standard size for background is just basically has to scale up to a screen resolution 1920 by 1080. So pixel background dimensions can be maybe 220 by 180, because that's 1/6 of 1920 by 1080, or 640 by 360, which is 1/3 of 1920 by 1080. So when making your pixel art, you should make your canvas exactly the number of pixels you want your asset to be, no bigger and no smaller. And make sure your pixel brush is exactly 1 pixel large, no bigger, no smaller. No anti-aliasing or any other effects that may make it so it is not exactly 1 pixel. Some people might do something they choose a square brush to draw with on a large canvas and call that pixel art, but that's not really pixel art, it's a pixel art style, which is not exactly what you're going for. So if your brush is exactly 1 pixel large, each next stroke you make will either completely overlap or just be to the side of your previous stroke. But if you're drawing with a square brush that you're treating as a substitute for a pixel, let's say you have a 10 by 10 square made by your brush, and then you just you draw more 10 by 10 squares with your brush. They can overlap, and that is not what pixel art is supposed to be. So you should make sure your brush is only 1 pixel large. When importing pixel art into Unity, since the image size is going to be really, really small, you just change the camera field of Unity to match the small size of the image file, so everything looks normal. But for raster art, which is just any non-pixel art, it's best to draw at a larger resolution and scale down if needed. And when you're deciding on the size of your art assets, just first decide on one thing to base the size of all your other things off of. For example, decide on the size of the background first and scale your characters to that, or decide on one character first and scale everything else off of that. So when importing your art assets into Unity, there's something weird you need to consider called pixels per unit, or PPU, in Unity. So the space on the screen in Unity, called screen space, scales using pixels per unit. And that is always set to 100 pixels per unit. You cannot change that at all. When you import a sprite, it will default to being 100 pixels and fill exactly 1 unit in Unity. However, you can change the pixels per unit of your sprite, so it can so it doesn't scale that way. Okay, now we're going to go into the hands-on part of the tutorial. So make sure you have the package downloaded from the GitHub repo, and also open up a new Unity 2D project to open the package in. Here, I'm importing my package. Whoa. So I'm going to start out with the pixel dog example. So open the sprites folder in the assets folder and go to your pixel dog. When you click on it, notice that on the right side, it will open up the inspector. Make sure the texture type is set to sprite, And the sprite mode, just change it to multiple. If it's single, as it is now, it's treating those two separate dogs as a single sprite, which I do not want. We want this to be separated into two separate dog sprites. So the polygon sprite mode is for if you want to cut your sprites into like polygons other than rectangle, because the multiple sprite mode cuts the sprites into rectangles. Let's say you want like a hexagonal sprite. That's what you use it for. We need to make sure to change the filter mode to point, no filter, and compression to none, because this is pixel art and it'll look very wonky with those other settings, which I'll show you in a bit. Make sure to apply those changes and open up the Sprite Editor now. Okay, so open up your Sprite Editor now. Wow, make sure to apply your changes. There you go. So you see, let's first just do the default settings: automatic slicing and slice. So automatic slicing slices based on alpha channels or transparency. You notice that the edges of the rectangle are like the furthest edges with like colored pixels. It slices very nicely because the dogs aren't touching each other, so it knows that these are separate. Make sure to apply your changes. And also you notice like you can rename the sprite here, and by default Unity will name your sprite like the file name underscore index starting at 0. So for the pixel dog, I think it's not that weird to name it like this, so we can name it what it is. But for other examples, it's not really good. Now you can like click open the sprite and see you can choose the sprite you want to put in. Okay, let's drag in this dog. Oh, zoom in on this dog. Okay, so remember that we have the filter mode on. Point no filter. Oh my gosh, pressure between none because it's pixel. We do not need something that's so low resolution to be compressed. So right now it's really nice and sharp and clean. So we switch it to bilinear. Notice it gets blurry. Same thing happens for trilinear. That's because the bilinear and trilinear filter modes are intended for raster art. They create a gradient to smooth out pixelation so stuff looks good on all resolutions. But obviously, you don't want that for pixel art, so always make sure filter node, get rid of the filter, and also make sure compression is none when you have pixel art. Okay. Done with the dog here. Let's move on to another pixel example. Go to the free pixel food folder, open the Sprite. I got this for free from the Unity Asset Store, which is linked in the GitHub repo if you want to use these sprites in your own game. So once again, we want to make sure we change the sprite mode to multiple. Okay, these are right. Apply your changes. Open the sprite. So notice how a lot of these sprites are touching each other. So this means that automatic slicing will not work very well. You see, these are clearly 64 individual sprites, but they're not being cut correctly because of like points of contact between the sprites. So a better way to slice this would be grid by cell size. So just trust me when I say that the pixel size is 16 by 16. I am bad typing. 16, 16. And here our sprites are sized correctly. But that kind of involves, I don't know, too much math. So I think the ideal way would be cut it by cell count, just by rows and columns. And this is pretty much 8 by 8. And it gets sliced all the same. So I guess you might be wondering like what these other settings are. So pivot is like, it's like the anchor point of a sprite. So let's say you want your sprite to appear at the center and your pivot point is the center. The center of the sprite will match up with the center of the screen. If you set it to like, I don't know, top left, then the top left of the sprite will be aligned to the center of the screen. So offset is like, it's kind of like some manual changes you make to how to change the pivot point in the sprite. And for padding, it's not a really good example here. I'll show you a better example of padding later. Okay, so let's look at these sprites. You see they're named food 0, food 1, food 2, food 3, when this is clearly like a cookie. And you can't tell it's a cookie from food 0, so you can rename the sprite here to cookie. And you can rename all those sprites in your own time. Also, like when you download this these sprites, the sprite sheet from the Unity Asset Store, it'll be all cut up for you, and also everything will be named already, so you don't have to like go through all 64 and name them individually. I just undid all of that so I can like show you in the tutorial what it looks like to code. You don't actually have to rename every single one of these if you get it from the asset store. Okay. So I think I showed you those like two like relatively normal sprites that like don't really cause problems if you use like the pretty much the default settings or just like mildly edited settings. So let's see some more problematic sprites, such as 40 and slip. 40 and slip is like raster art, so we don't need to change the filter mode. But let's look at him. So it's intended that 40 and slip switches between these three poses. So if we slice it automatically, each sprite ends up with different size, which could be annoying for programmers to implement animations for, because like you might like, instead of like staying in one place, you might just like jump around on the screen when switching between sprites, which is probably not what you want. So a somewhat better way of slicing such that the sprites are the same size is just making like 3 columns. And here you can, let's look at what padding does. So 10 by 10. See, the padding is just like, it like deals with if there's like spacing between your sprites. Like with the, see there's like the X direction and also the Y direction. This obviously doesn't really work out well for 40 and slip because we're cutting off his books, but another weird sprite sheet is stapler sprite. And open the Sprite Editor. So for the stapler sprite, we want this bottom stapler along with the staples to be its own sprite. So the problem is if we like set something, let's say automatically, it doesn't do that. It separates all the individual staplers or individual staples. So for this, we want to instead manually cut out the sprite. So just click and drag on the canvas. Around here. And there you go. Future staplers. But it's kind of a hassle to also do that for these other two. So we can change the state. We can also like rename the sprite. We can rename this like. And then we can automatically size now. So the save method, it maintains your previous selection size. Like it also keeps the name of your sprite. Okay, but let's say you slice automatically and method is delete existing. So that just deletes the sprites you already have, and also it doesn't maintain your names. You see like that this is stapler, and also the names of these disappear too. Back. Our method like keeps like, it like tries to figure out what's like the smartest way to do things, which might not work, but you see like here, it kept the name of these sprites, and also like they didn't change the slicing because it's automatic, so it thinks that I do want to automatically slice those sprites. But yeah. Yeah, you see like after I delete existing, it rewrites the names of the sprites too. So you know like now you know that it redid the sprite cutting and just like deleted the previous changes. So, we have our separate stapler sprites. Yay. Okay. Well, that's it for my spreadsheet section.
Hi everyone, I'm Zoe and I'll be teaching the Tilemaps portion of this tutorial. So a tilemap is essentially a grid that allows you to place sprites or tiles into your game in order to create environments and or streamline the level building process. So essentially you'll have a tile set, which is a collection of tiles or like regular sprites that are all the same uniform size, available to use on your tile map. And in Unity, you usually create these tile sets by slicing an image, a sprite that already exists. And then you'll be creating a palette out of that, and you can essentially paint it onto your scene in any configuration that you want. And so that's really useful for building, larger levels, so you don't have to create everything from scratch. And so you can really do an infinite amount of levels with just a small tile palette. And it also, you can use it to lay down other assets, other sprites that you may need, even a full prefab game object, which we won't be going into too much today, but just stay tuned and I'll talk about that a little bit later. So the first thing you're going to do is make sure that you have the correct assets imported. You should all have it in the package that you downloaded in this tutorial assets folder. And you're going to find the sprite labeled TX tileset ground. My folder looks a little bit different from yours right now because I have all this extra stuff because I've already created a palette. But you're just looking for this guy right here. He should only have this little pop up here, nothing, only just one set. So you're going to click on this and then you're going to go into your inspector. And when you find sprite mode, you're going to go change it to multiple. And you should be able to click apply. I think when I reverted things back to reset it from the first time that I went through this tutorial live, I forgot to click apply, but please do not forget to click apply. So once again, you're going from single to multiple, and then you're going to click apply. And make sure your pixels per unit is 32. You'll see why in a second. Just for now, make sure that it's at 32. And so now we're going to go into our Sprite Editor. Hopefully you should see that window on my screen. And so this is our Sprite Editor. Ray should have already gone over it a little bit in the Sprite Sheet portion. So this slice button, which if you have a narrower window, you might not see that it says slice, but this is the slice button. It's the second button from the left. And so you're going to click on that little down arrow. And on type, for this one, we want to grid by cell size. You can also grid by automatic, but what that's going to do is it would not give you individual tiles. That's more for slicing into a sprite sheet that has more irregular like objects that are not all the same size and that are separated with negative space in between them. You can also grid by cell count if you know the numbers of tiles across that your sprite is supposed to represent. Again, whether or not you want to choose cell size or cell count is really up to you. You just have to know the proper information. That's something to talk to your artists about, or if you're doing the art yourself, just make sure you know that information. If you can't figure out that information, you can look and see how many pixels across over here the actual asset is and sort of guess how many across that means when we see like this as a tile here. That's kind of a last resort sort of thing, but I'll show you how I'm going to do it and it should make sense. So I'm going to grid by cell size. And so I happen to know that each of these tiles, so you can really see this one floating tile here. That's how big they're all supposed to be. And I know that the artist has made this to be 32 by 32 pixels across. And so that's what I mean when I say you should know what the size of each of the tiles is going to be if you want to grid by cell size. And then if you want to grid by cell count, you'd have to know how many of these tiles across the entire sprite is. I don't know that for this image, so I'm going to continue with grid by cell size. So we're going to do 32 pixels by 32 pixels, and we're going to click slice. So as you can see, this has sliced them all into individual tiles that are all the same size. And again, when I said, if you don't know the size they are supposed to be, this is 512 by 512. And if you can kind of guess how many across they will be, you can sometimes guesstimate. I don't recommend that. I would recommend knowing that and making sure you know that information from the get-go. And you'll easily be able to see if you have it wrong, because it won't be able to, your sprites won't all be cut into the right size tile. Like this is a really good reference, because you can see that this floating tile here is perfectly in the square that it's given it. And so again, you're always going to click apply so that those settings will save. And now they've saved. And so that's how you're going to cut them up. And so the next thing we're going to do is we need to actually prepare to get this into our scene in Unity. So if you haven't already, open up a new scene. And so what we're going to do is we are going to create a new game object. So right click, go to 2D object, Tilemap, and we're going to make a rectangular tile map. So this will mean that they are all squares like we saw in our sprite. You can also make a hexagonal tile map or an isometric tile map, but those are different shapes and they're a little bit more complicated art-wise to make. The actual process in Unity is the same, but again, you have to have the right assets to be able to use those, and ours are rectangular, so we're going to click rectangular. And so you can see this created a grid with a child being the tile map. And you can now see in our scene view, this big grid here. This is not going to look the same in your game view. This is just for our purposes of knowing what's going on here. And so if you don't already have the tile palette window up, sometimes there's a pop-up right around here asking you if you want to open up the tile palette window. If not, you can go to Window, 2D, and Tile Palette. And that will open up. See, I already had that window up, so it just automatically went there. I already have it imported, but I'm going to show you how to add that. But first, we're going to make sure that our settings on the in the inspector on the actual tile map object are correct. And so what we're going to do is we are going to add a couple of components to this, which I will explain later. So first we're going to add a collider, a box collider 2D. And now we're going to add Composite Collider 2D. And that will automatically add rigid body as well, which controls the physics. And then we're also going to add a platform Effector 2D. And this is because I'm going to be showing you how to make a platformer tile map setup. And I will explain these in a little bit more detail later. So we're going to move on and ignore those for now. Just make sure that we have everything ready to go for the next part. So in our tile palette, what you're going to do is you're going to click this drop-down menu and you're going to create new palette and go ahead and name it whatever you want. So grass or grass palette or something like that, or platform palette 1. Name it whatever you want. Keep it at rectangle, keep it at automatic, keep it at default, keep it at all those settings and click create. And it's gonna open up your your files, and you're just going to have to save it to the correct file folder. And so now we have an empty palette here. So what we're going to do is we're going to go back to our asset, and this little guy here, we are going to grab it, this one that we worked with before and sliced, and we're going to drag it into the tile palette and drop. And again, it'll open up your folders, choose where to put it, wait for it to load, and now you can see it here. And look, if I click on these, they're all their little individual tiles. And so now we're going to learn how to draw into our scene. So I'm going to go over these tools. So this is the select tool. If you've worked with Photoshop or an art program, these tools should be very familiar to you because they're very, very similar to other art programs. So the select tool kind of does exactly what it says. You can select a portion on the grid in your scene, and it'll keep selected, so you can do whatever you want to that. This move tool is move selection with active brush. You see how I had that selection there, and now I can move it anywhere I want. This is very helpful if you realized you drew something in the incorrect area and you just want to select a large chunk and move it somewhere else. This is the most important tool because it's what you'll actually be using to paint it in. It is the paint tool. And so while you're on the paint tool, what you're going to do is you're going to, whatever tile you have selected is the tile that you will be using. See, if I hover it over my canvas here, I can put this tile anywhere because it's the one I have selected in the palette, and I'm on paint. So you can click and drag, just lay those down and get practicing with it. And while I'm here, I want to scroll in so I can show you that these tiles more or less match up. These actually, that was probably a bad example because those don't actually fit together from the drawing. Let me find some that do. Yeah, that's a little bit better. Oops. Yeah, so you can see these fit together seamlessly. They all fit exactly into the grid. This is because we have our pixels per unit at the same size that our tiles are, so 32. If you have it at a different setting, it'll look very strange. So I'll actually just show you an example of that. Actually, it might be a little bit hard because I've already imported it, but essentially here's where your pixels per unit are. If I had this at a different number, such as 100, these tiles would still be on the grid, but they would not fit exactly. So hopefully that makes sense. You can mess around with it if you want to see for yourself. I just don't want to mess up what I have here right now. So, okay, the next tool is paint a filled box with active brush. So again, I have this brush selected. And so if I want to fill this entire area, I just drag and release. This is very helpful, especially for these like ground sort of pieces that are more fill, if you want to create like something really tall. And then maybe you have a lot in your palette, and you know in your actual scene which brush you want to use. You're like, oh, I want to use the one that I used here, but I don't know where it is on the palette. So then you're going to choose the select tool, the select new brush tool. It's like a eyedrop tool, and you just select wherever you want it. Now I have that brush, and that's very helpful. It makes things very quick to do, so you don't have to go all the way over in here to select it. You can kind of just go to something more close to you that you're already working on to sort of get where you need to be. And so I encourage you guys to play with this and build your own. There's also the erase tool, which does exactly what you think it does. It erases things. And then there's this fill tool, which is different from this fill tool in that it has to have, it kind of fills in a space that already exists. So a better example would be if I drew in with my brush a box like this, then I can fill that in easily. Or you can, as I see, I'm just kind of hovering my mouse over, and since it is a grid, it'll just fill in sort of like the box fill does. But I don't actually have to draw the box. It's just, it kind of goes where it wants to along the grid. Again, another very useful tool. But yeah, I encourage you for the next couple of minutes to play around. You can pause this video as you go and create your first sort of environment with your palette. I'm going to create my own, and I'm going to create a little platform that's actually quite tall. But again, if I want to move it, I can select this and select this, and then I can move it. So I'm going to move this down a little bit. For our purposes, I'm just going to create a couple of small platforms, not really caring what they look like. And I'm going to create one up here so I can show you the next portion. So I'm going to save that. Again, go ahead and pause this video now because I'm about, if you want to keep working on your platforms, because I'm about to go into the next portion. Okay, so let's go back to our tile map and notice that I added these that I had you add earlier, all these components. So if you don't know what a collider is, a collider means that it is like an invisible box or invisible border that is put around a sprite that allows other sprites and other objects rather, to interact with them. So if two colliders, two borders of game objects that have sprites on them collide with each other, then that does something. And what that does depends on how you program it. And I'll show you how that works because we're going to put a player in our scene. First, we're going to change some settings here, though. We want to make sure that since we are using all these together, the settings are correct and that they will work with each other. So the box collider 2D is adding colliders to these objects. You can probably tell, I don't know how easy you can tell on this, but there are colliders right now. There should be a collider around every single one of these tiles right now, but that's kind of a lot and you really don't need them because your player is not going to be moving like in each of these individual tiles as separate objects. So what we want to do is we want to use click the use by composite, and this will make it used by our Composite Collider 2D right here, which is essentially for Tilemaps and makes it so, or mainly for Tilemaps, and makes it so that these adjacent tiles will all have a border around the entire thing rather than each individual tile. And so actually we have to change a couple settings on this as well. On rigid body 2D, this is the physics, if you don't know, which basically shows how things move in your scene, simulates gravity. We're gonna move this to static, which will essentially make it so that our platforms don't fall off of the screen. They just stay in one place. They are static objects. And then let's go to our platform Effector 2D, and I'll explain what that is. You'll see it more when we're actually using the player, but essentially this allows you to make platforms that actually function how you expect them to in the game. You can use one-way colliders, which basically means that, for example, I could jump through the bottom of this, but land on the top, as we will see in a moment. But in order to make that work, we're going to click Used by Effector under Composite Collider 2D, and you'll see this arc pop up. So we're going to save, and what we're going to do, I have a prefab player for you in here. It's just a white square, and you're going to drag that into your scene to add it. And you're going to move it so that it's somewhat on top of this platform, but below the one above it. And what we're going to do is look to check to see, yep, it already has a collider and rigid body 2D. We actually want to make sure that collision detection on our player is continuous. And then we're going to click save. And I'm going to show you what this looks like right now in our game view. So we're going to go into game view and we're going to click play. So this guy, okay, actually we're having some issues right now. Let me fix those and get back to you, because what should be happening is he's able to move, but there's something going on with our colliders right now that is not allowing him to detect where my platforms are. And I think I saw that problem before. So let's just troubleshoot this right now. We have our grid, we have our tile map. We have our box collider 2D, we have our rigid body 2D. It's set at the correct settings, but why are we not seeing a collider? Why is, how odd. Let me figure this out for a second and I will get back to the tutorial in a second. This is not an issue that I had last time I was teaching it. So hopefully you don't have this issue and maybe it's just me. Okay, everyone, I figured out what the problem was and I had you guys do the wrong thing on accident. So I've kind of removed those components for now from my tile map and we're going to add them in again. You are not using the box collider 2D, you're using the Tilemap Collider 2D. Now it looks like it's supposed to. So you are going to have a collider on every single tile. And so now we can really visually see how much that is, like how excessive that is, because this will really affect your game's performance if you have all of these unnecessary colliders that are all individual. And so that's why we need the Composite Collider 2D. And so now when you can see that I click Used by Composite, boom, we're all composite there. And this will continue when you draw new tiles. So it won't just like add an individual tile to the end of this. If you add it here, it'll continue as long as they are adjacent to each other. It'll count them as a composite for the collider, which is very nice, very handy. Once again, we're going to shift our rigid body 2D to be static. And we're going to add the platform Effector 2D. And we're going to click Use by Effector on our Composite Collider 2D. And again, we have this little half circle right here, which I'm going to show you what that does. So now when we go into our game view, we're going to see that it's all working smoothly. I don't know why there we go. Sorry, my player was a little bit stuck. So we move him with WASD keys. I don't know why he's doing this right now, why he's being weird, but in any case, if you click to W to jump up, you can see that he goes through the bottom of this platform and lands on top. So I'm going to show you why that happens. Just a second. Okay, so if we're going back to our platform Effector 2D, we see that our little zone here is a half circle. It's 180 degrees under surface arc. That's what makes it a half circle. And so what that means is that essentially for the one-way collider effect, that means that everything that is above this horizontal axis, this 180 degrees, is going to be in the zone that is affected by the collider. In other words, the bottom of these colliders is able to be passed through by other objects, but the top is not. So if I switch it to 360, now I have a circle, which is showing me that everything, all degrees of this, all 360 degrees around this plane will be affected by a collider such that you can bump into it, but you will not go through it. And I'll show you what that looks like in play mode. So now, if I try to move our player again, who's getting stuck, I can't, look, he just bounces off. I can't go through it anymore. So that's how that works. And you can change it to whatever, you can change the surface arc to whatever number of degrees that you want. And why you would want to do this is that so you can create different effects with your platforms. And this is how you get more interesting level building. So basically you can also use this to have platforms that are at an angle that you can slide off of, that you can bounce off of. You can have wall climbs that you can bounce off of on a vertical angle. You can basically do whatever you want, but for now we're going to keep it at 180. And that is pretty much the gist of the platform effector, at least from a simple sort of a simple explanation of it. And so I want to talk a little bit about what I mentioned earlier in the tutorial at the beginning, was that you can also use a tile map to place objects, game objects that you want to be repeated without having to drag them all individually in. And so how you would do that is you would create what's called a prefab brush. So if you don't know what a prefab is, it's basically a game object that all of the settings, whether it's Sprite, all the components that you have, any code that you have attached to it, will be contained within that game object. So you can essentially copy it easily into other scenes so you don't have to build it from scratch. And that's what this player is. The player is a prefab. So you notice that when we dragged it into our scene from this folder, that it already came with all of its components and code and everything. And that's because Athena, when she created this prefab for one of her tutorials last year, she created the player by itself. And essentially, all you have to do is you have to drag the game object from the scene into a folder, and it'll create a prefab. And then it turns blue to indicate that this is a prefab. This might have been covered in other tutorials, or it might be covered in other tutorials that you haven't seen yet. But just so we know what that is. And a prefab brush, I do not have the package to work with that right now. I didn't have time to prepare it for this tutorial. However, in the README, I have included a link that's only 3 to 4 minutes long, like less than 4 minutes. And it is a really great YouTube video on how prefabs are made and prefab brushes are made and how they're used. The example that they give in the video is that if you have different colored gems that you have to collect as a currency in your platform, instead of individually putting them in your scene, you can essentially turn that prefab of that game object into a brush that you can use, like the brushes in our tile palette, to paint it along this grid. And you can also create it to randomize for different game objects. So you can have a blue gem and then a red gem and then a green gem randomized throughout. Again, I don't have the information for you in that tutorial this time, but that YouTube video that's linked in the README at the very bottom is very easy to follow, very short if you really want to get more into Tilemaps, and especially if you are planning to make more platformer games, because I think that's a really useful tool to know about. But for now, sorry about the issues today. I've kind of had a bit of a rough day the day that I'm recording this, but I hope it was easy for you to follow anyway. If you have any questions, don't hesitate to text us in the Discord. And yeah, have a nice day. Play around with it. Thank you.